Hello, SYNGAP Lab. My name is Michael Graglia, and this is episode 88 of SYNGAP 10, your 10-minute weekly briefing on everything you need to know about SYNGAP1. Today's Monday, January 9th, and I did episode 87 last week. And then on Thursday, after I dropped episode 87, we announced our grant to the Patrick Wild Center at the University of Edinburgh to Professors Cobb and Kind to work on an AAV for SYNGAP1. This is a huge grant for a couple of reasons. First reason it's huge is this was co-funded by SRF US, who you know and love, that's us, and SRF UK, who is an SRF branch that is established in the UK, was established by Katrina, and is now led by Julian, Ray, and Don, and Jonathan, and others. And we are co-funding it. So that's really exciting to see the UK community come together and raise money with the US community and to make this substantial grant to Professors Cobb and Kind to work on AAV9 delivery of SYNGAP1. So let me just read you from the press release, and I share in the show notes links to Facebook, LinkedIn, Twitter, and the actual release. Please go and like those, comment on them, share them out, let people know that this grant is happening. It's a really exciting grant. And just to remind you, when you're dealing with precision medicine means we know exactly what's causing the disease, the problem with SYNGAP1, and we have a way of going after SYNGAP1, as opposed to throwing a drug in there, Depakote, Epidiolex, Onfi, whatever you got, and hoping that somehow it manages some of the symptoms. No. We're going to go right to the root cause, and we're going to deal with it. That's what precision medicine means. And there's really two different ways to go after, broadly speaking. There's two different delivery mechanisms to go after a haploinsufficiency. There's an ASO, and there's an AAV. And there's a lot of different things about them, but the V in AAV is viral, right? So an AAV conceptually is one and done. You stick it in the body, it's a virus, so it replicates, and you get a lot of copies of the machinery you need, and those go and target. So conceptually, you're one and done. ASOs, you have to deliver, and then you have to deliver again a few months later, and there's pluses and minuses to both of those. But most of what I've been talking about have been ASOs. Stoke is working on ASO with Acadia. Praxis is working on an ASO. Ionis works on ASOs. We remember Q-State has talked about ASOs. But there's people like Camp4, who I mentioned before, and now Professors Cobb and Kind, thinking about, okay, what about an AAV, right? So this is a little bit into the future, which is why it's great that we get Professor Cobb working on this. And I want to tell you a funny story about how this grant happened. I have been staying very close to an incredible MD, PhD, and leader in the rare disease space named Dr. Yale Weiss. And Yale and I were together at a meeting, probably an Angel meeting, I don't remember, over a year ago now, maybe 2 years ago. And we went out to dinner, and there's this very nice guy, Stuart Cobb. Hi, Stuart, what do you do? Oh, I do AAVs. Really, what diseases? Dravet and Rett. And blah, blah. I was like, well, why are you doing SYNGAP? He said, well, I don't know. And that was the genesis of this grant, right? And then as soon as he said he was at Edinburgh, I said, well, do you know Peter Kind? And he said, yeah, Peter's across the hall or next door or whatever he is. And I was like, oh my gosh, Peter Kind has, and then Stuart says, yes, I know a lot of Fragile X. I said, and SYNGAP1. So you got Peter Kind, who is this incredible leader of the Simons Institute for the Developing Brain, aka SIDB, at University of Edinburgh, that has all of these mice for Fragile X and SYNGAP1. And then you have Stuart Cobb, who's doing AAVs for Rett and other rare diseases. And you're like, Stuart, you should do SYNGAP1. And then you got Stuart working on SYNGAP1 right next door to Peter, who's got all these mice, rats. That's how you make progress happen. You get the best in the world who happen to already be literally next door to each other, and you incent them to work together by paying the bills. That's what this patient advocacy stuff is all about, friends. So I'm going to read you this grant. There's a lot of other stuff I got to talk about. Just got to read this to you. Two-phase project. This is in the press release. Two-phase project aims to assess the effectiveness of SYNGAP1 vector. Vector is the AAV in rats modeling disorder. Rats, because Peter's got a lot of rats. In phase 1, the team will run experiments to establish the transduction efficiency and tissue biodistribution of AAV9/SYNGAP1 in brain regions after intracerebroventricular injection of vector in wild-type rats. What on earth does that mean? They're going to stick an AAV9 directly, they're going to inject into the skulls of these little mice, or little rats, and then they're going to sacrifice the rats, and they're going to cut open the brains, and they're going to see how much that AAV spread and where the brain took it up. Right? That is important because if we're making a medicine to get to neurons, we got to figure out if the thing we're using, the viral vector, is going to get to the neurons. So that's phase 1. That's just phase 1. How incredible is that? And it's better that we sacrifice some rats and figure this out in rats before we start doing this to humans. During phase 2, they will test the benefit of ICV, intracerebral ventricular, the things in the cerebellum, the brain, of AAV9/H SYNGAP1 in male SYNGAP plus minus, plus meaning working copy minus meaning knocked out copy, aka haploinsufficient, aka like our kids, male rats in terms of key neurological and behavioral phenotypes. So what that means is Dr. Kind, Peter, has these incredible rats and has ways to measure them, and he knows what a normal rat looks like, and he knows what a SynGAP rat looks like. So then we're going to take the SynGAP rats, stick this medicine into them, and see if the SynGAP rats behave more like the human rats. And Dr. Kind can actually measure that. Mind blown. The goal of this 2-year project is to generate proof of concept efficacy and non-GLP safety data that would support a potential future IND submission for SynGAP1 gene therapy. We are laying the foundation for a new class, another class of medicines to work on SynGAP1. And we are doing it with people who have done it before in the rats and who have done it before in other diseases that are bigger than ours, like rat. Like, we got to remember, there's Dravet, there's Rett, there's Angelman. I think those are the big ones. Dravet, Rett, Angelman, and then there's the next wave of monogenic diseases, and we are ensuring that we are in that wave. So that's super exciting. The other thing that's super exciting is right now is JP Morgan. So I was at JP Morgan. There was a small event kickoff last night hosted by Ultragenics. I'm a huge fan of Ultragenics. And actually the cover of this podcast episode is going to be a picture of me, my beautiful wife, Ashley, Allison Burnett from Angelman, and Dr. Emil KAKIS and Dr. Yale Weiss, all in one picture. And it wasn't staged. We were just all together, and someone's like, picture, probably Allison. And so we took this picture, but it's a great picture because there's me and Ashley, there's Allison, who is like the force of nature behind FAST. And then there's Yale, who I already alluded to, and has just been a great mentor and guide and cares deeply about SynGAP. And then there's Dr. Emil KAKIS, who's a giant. Go read his book, Saving Ryan. I'm actually going to put a link to that book that into the show notes right now, because Saving Ryan is a great book. And if you read that, you'll understand that Dr. KAKIS is a giant. So, and I'll also put a link to Allison. But Rare Affair was great. And the thing that I took away from Rare Affair is Dr. KAKIS was talking about, okay, we're making all these great diseases. And it was really about all rare disease. We're making all these great treatments for rare diseases. And what we have to do, his call to action in the few moments he spoke was, we have to work on biomarkers, because if we don't have biomarkers, we're not going to be able to measure what we need to measure in clinical trials to get these drugs approved. Amen, Dr. KAKIS. And then today, as I'm getting ready to write this and prepping my show notes, Jacob Donahue from Beacon Biosignals, which I've alluded to before, wrote a little piece on LinkedIn that I share in the show notes saying about how important it is and how exciting it is, and that companies like Beacon and others can and should be working on digital biomarkers for precision medicine in the central nervous system, which is all SynGAP1 is about. So it's kind of all coming together, right? The path is very clear. We're funding key work with some of the world's best, Dr. Cobb and Dr. Kind, and we're talking to the leaders in the space, and biomarkers are the issue that we need to tackle next. And we are already in conversation with people like Jake about what would a digital biomarker look like. Like, the future is coming fast. And this is verified by a couple things. Okay, commercial break. I want to remind every family who's listening, if you haven't signed up for your Rare Bear, by the way, I was on a conversation with the head of the Rare Bear Foundation, who also does other things, and we were talking to another organization it's too early to tell you about, and she was introducing us, and she said, when I started the Rare Bear thing, and Rare Bears is anyone with a rare disease can sign up and get a bear custom made for your kid. They're adorable, they're cute, you should do it. And she said, when I started this years ago, like, SynGAP had like 8 Rare Bears. And she's like, and Mike and the SRF team just really emphasized them and pushed them out for the recent meeting. And I just checked, and we've issued 80 Rare Bears. And what that tells me is that we only have about 1,000 more Rare Bears to make for every kid with SynGAP in the world. So if you sign up on our website for a Rare Bear, anywhere on earth, they will make the Rare Bear to your spec, the color you want, the design you want, the whatever, and they will ship it to you and your loved one. How cool is that? Get a Rare Bear. Okay, back to the news. SynGAP1 is in Beyond the Ion channel. Dr. Ingo Helbig, who made that incredible poster that I talked about and I shared on Twitter. And if you haven't, if you don't know the poster I'm talking about, this poster is fed by citizen data, and I tweeted it out, and you should definitely know about that poster. But he did an update to Beyond the Ion channel, and in that he talked about SynGAP's relationship to Deuce syndrome, how genopheno is hard, but Jillian used the citizen data to make it, and the incredible community that we have here in SynGAP1. So that was cool. Thank you, Dr. Helbig. Dr. Helbig matters because his blog, Beyond the Ion channel, matters because a lot of neurologists read it, and we want neurologists to understand what SynGAP1 is. Super cool. More exciting news. Dr. Heller, epigeneticist and anti-SynGAPian at UPenn, one of the best universities in America, has been funded for another year by the $1 Million Bike Ride. And let's double click on the money here. We, through the $1 Million Bike Ride, raised, I think, about $35,000. Thank you, Aaron Harding and Peter Halliburton, for your leadership here. Aaron has been driving the MDBR for some time. We raised 35,000, but because we are a matching funds team, UPenn put in another 30,000. That adds up to 65,000, which is exactly how much Dr. Heller needs to fund a postdoc for another year. So we raised 35,000. Penn graciously put in 30,000, and now we have another postdoc in Dr. Heller's lab for another year. That's a win for SynGAP. Congratulations, Dr. Heller. Thank you, MDBR. Thank you, Aaron Harding. I allude to if you're like, who's Dr. Heller? Go ahead and watch episode 14, links in the show notes. And then one more piece of great news, and then I'll go because I've got to be over time already. I am. It is what it is. If you remember a little while ago, in partnership with Overcome, SynGAP, which is the French-Canadian organization, and other SRF Canada families, we have been raising money for Professor Bowie. Professor Bowie has a combination therapy that we're not allowed to talk about the names because we're under NDA, but he's basically worked on this therapy for another disease, and he came to us. He said, I think this will work on SynGAP1, and I need you guys to pay for the mouse work to de-risk it so that I can give it to a pharma company to take it forward for SynGAP1. And we were like, it's kind of weird. And then we talked to him. We did some diligence. We signed some NDAs. We read some stuff. I talk about this in episode 75, links in the show notes. And guess what? We were like, whoa, this is pretty exciting. We're going to fund this work. And what I share in the show notes is a link by the CEO of his company, NOS Pharma, that Professor Bowie created with the CEO. And you can click through to their webpage, and guess what you see on their webpage? You see their pipeline. And guess what's on their pipeline? 2 diseases. One of them is SynGAP1. And we played a part in that because we supported Professor Bowie's lab to double click on SynGAP1. This is really exciting, right? If this drug, if he proves concept and NOS Pharma runs with it, guess what, friends? We are one step closer to one more therapy indicated for SynGAP1. That is a better quality of life for our loved ones. That is more hope for our families. That is everything that we want. That is why we're here. So very exciting week. I'm sure there'll be more good news to come, but I'm pretty stoked right now. A lot of good things happening. We should be proud of ourselves. We should continue to work together, to be a strong community, to be hopeful, and to collaborate, because we're getting great work done, friends. There's a lot of seeds in the ground we haven't even begun to harvest yet. Keep going.